Good day, guys. Travis here, Efficiency Hobbyist. So today's topic, heat pump washer dryer all-in-ones. So worth it, not worth it? Would I buy it again? Why did I buy it in the first place? Today, we'll get into all of it. Okay, so let's talk about what this unit is. This is a heat pump ventless all-in-one combo washer dryer. And what you're probably asking is, well, how can a dryer be ventless? So instead of having your typical vent that would just run all the hot, humid air out of your dryer drum and dump it outside, this actually creates a heating loop within the system that has an AC condenser that actually causes that humid air to condense on the coils and drip down into a tray, which then evacuates the same way as your washer fluid will. So there's a pump in there that actually just pumps this to the exact same outlet that your regular washer would normally plumb to. And you don't have to worry about any of the air that's in this unit going outside, which is kind of cool. And as it turns out, it's a good bit more efficient to do it this way too. So I'd kind of had my eye on these for a while, and I was more or less just waiting for my either washing machine or dryer to bite the dust. And eventually that did happen in June of 24. So there were three main companies that met all the criteria for this whenever I was originally looking for these. The first of them was this GE unit, which has just slightly smaller than a 5 cubic foot drum. Option 2 was an LG unit wash combo. Now they do make this in an individual heat pump dryer and washer, but this is the all-in-one specific unit, and it comes with a 5 cubic foot drum. And last but not least, Samsung has their Bespoke line. It comes with a 5.3 cubic foot drum. Guys, if you are looking at this one, I will caution you a little bit. Make sure that you're very specific about the unit that you order, because this exact same model comes with both vented and vent-free applications. So as a surprise to no one who saw this in the background of the intro video, I did actually choose the Samsung model for a few specific reasons. One of the reasons I chose it is it did have the largest drum size available, and I was honestly a little concerned that I was going to not have enough space in these. That ended up being totally fine. I can easily wash a king-size comforter by itself in this drum, and I have no issues. I did get it on sale through Lowe's on a 4th of July benefit, and I did actually also have the 5% off because I had the Lowe's credit card. But honestly, all of these systems were almost an identical price at the time. It was just you had to shop around a little bit, and that was basically just the going rate to get one of these. The benefit to being last to market here is I think they had a little bit of time to look at what people had reported as some of the shortcomings from both the GE and the LG models. People had some complaints about just not being happy with how they performed in some circumstances. And we'll take a look at the two main reasons that actually pushed me to this, even more so than the drum size. Here's an example of why a lot of people, I think, will prefer this unit over the other two. So you'll notice as soon as this finished drying, it automatically popped that door open. While this seems like a pretty simple feature, what this actually does is fix one of the biggest problems that people had in terms of complaints from the other units. So one of the big things that a lot of people didn't like about the other two units is that whenever they opened the drum and they pulled their clothes out, they still felt mildly damp. And they actually addressed this in the user manual, stating that your clothes are dry, but they may feel more damp than you are used to. So what this does is by popping that drum open at the end, it allows that drum air to come out and be replaced with less humid room air. So the reason this occurs is that if you think about how this is actually working, these are pulling water out of this drying loop via condensation. But you can only pull so much out via dew point condensation. So in this loop, you'll still have a higher humidity running in the actual heat loop than you do in the room air that's in your room. So when this pops open, you then share the room air, and as long as you aren't immediately going ahead and getting those clothes out of the dryer, it gives them time to actually finish drying while they're still in the drum. The next fix isn't necessarily one you can see or feel, but it makes a pretty big difference in terms of overall performance. That last shot was a picture of the condensing coil. So what happens for some of these units, especially the first two, seems to be that if you can't filter out 100% of the lint from that dryer circuit, some of it passes through and gets stuck on the condensing coil. So what this unit actually does is it has a row of sprayers at the very top of this, and it actually sprays front and back onto those fins and lets it rinse that lint down off of them. So guys, that's a shot of this thing, and I have never once in the over a year and a half since I've owned this actually got in there and cleaned those coils, and they were still a lot cleaner than I actually had anticipated. Final note though, you are actually supposed to clean these annually. Okay, now you guys know what I chose and why I chose it. Let's get into some of the potential drawbacks that you'll see. And probably one of the largest hurdles that you'll get with a heat pump dryer is what's on screen now, and that is the amount of time that it can take to actually run one of these loads through. And while it may not always take as long as it assumes that it's going to take initially, 3 hours and 41 minutes is still a pretty long time to do a load of laundry, both wash and dry, in my opinion. This does seem to be a drawback of the specific unit that I chose, as some of the other units in the list actually were capable of doing loads faster in some of the other reviews that I saw online. The next issue we probably need to talk about is level of dryness of the clothes. So while it is better with this unit, I do find that if I'm doing multiple loads back to back, that whenever I pull the previous load out, sometimes there are certain items in there that are still a little bit less dry than I would maybe like them, usually jeans or towels or something that's kind of heavy. And it's very common to have some things in the load that are completely dry and some things in the load that are still a little damp. Rarely ever do I ever pull anything out of there that is so damp that it would give me concern for, oh, if I fold this now, this might mold. I think people kind of underestimate the amount of wetness that it typically takes and the length of time that something has to be wet for to cause mold. I've never pulled anything out that I've folded slightly damp and it smelled musty or had any sort of odd odor. It smells clean. It smells just like the fabric softener and the detergents that I use. But it is a little off-putting and it is a little odd to get something out of the dryer and it not be totally dry. Now, some items inherently are going to take more than potentially one dry load. Large, like feather comforters and things like that come to mind, but honestly, my old electric dryer usually never dried those in one round either. So that's not a deal breaker for me, and it has never caused any big problems. Maintenance is another area where people are usually pretty used to setting a dryer and leaving it alone. Yeah, absolutely. You should change the lint trap and clean that out between uses. Occasionally you do need to make sure that the dryer vent tube to the outside is clear. Otherwise it is a fire hazard. But a lot of people just aren't used to having to clean the coils out or vacuum the inside of the unit in some of the components. And that's honestly just part of the nature of having a closed circuit where none of this air blows outside. All of this air just continues to circle around inside the heating unit loop, and it just doesn't ever have anywhere to go. So yes, there can be some lint that accumulates in different places in this. It does lead to some additional maintenance. Again, it hasn't ever been a problem, and as I stated earlier, I have never actually cleaned the fins off of this unit, and to date, I've not had any problems with it. Expense is probably another topic that does need to be talked about a little bit. Obviously, for a high-end washer and dryer, $1,700, while a lot of money, is really not out of line for what the individual units would be if you bought them. Now, absolutely, you can buy a washer and dryer set for roughly $800, but it's not going to have the same level of amenities or capabilities of some models. So yes, it is expensive, but basically replacing a washer and dryer is going to be rather expensive no matter what. So not a deal breaker for me. App integration. So this unit does have an app integration. It does, however, use Samsung's generic SmartThings app ecosystem. So if you're already a member of that ecosystem because you have their TVs or other appliances or something, you'll already be familiar with it. One thing I have noticed is I've been very unsuccessful about keeping this connected to the app. The longest I've ever actually had this connected to the app and it working was long enough to do an actual update to the unit. And since I've done that update, I've tried multiple times and I cannot get this thing to reestablish connection with my router, despite turning the unit off, turning the router off, all kinds of things. This isn't a big deal for me because I can't use stuff like time of use scheduling or anything like that. West Virginia just has flat rates on electricity. So honestly, I don't ever use the app. If it did work, the only thing I would do is probably specifically monitor the energy usage. But I can do that with my Emporia Energy View. And personally, I would rather do it from there anyway because that's where all the rest of my data is. So not a problem for me. Wrinkles. So this does have a setting that you can, check box, and it's supposed to reduce wrinkles. But let me be very clear that in terms of comparison to a regular electric resistance dryer, these for sure have more wrinkly clothes. And unlike a regular dryer, even if you throw, a particular item back in and allow it to go through another dry cycle, maybe with a damp cloth or something, it doesn't necessarily seem to come out any better than it was. It just comes out slightly damper than it was when you put it in. So if wrinkly clothes are something that really puts you off, they aren't always terrible, but even if you get them out immediately and fold them right then, they are more wrinkly, I feel, than they would have been on any time that I used a regular dryer. That, I think, ultimately probably wraps up most of the cons of these units. Overall, I feel like this unit, at least for me, offsets the cons. The greatest one usually being the amount of time it takes to do a load. But if I'm being honest, the benefits of this being an all-in-one, so me not having to remember to take something out of the washing machine and put it in the dryer, that alone offsets all of the aggravation of how long it takes to do a load. And I find that I just do more loads throughout the week. Usually I'll throw a load in before I go to bed and wake up and it's done and the drawer has popped and everything that's in there is completely dry. So really, I don't feel like I've had any, I don't feel like I lost out on anything by going to the heat pump, dryer and washer this time. And with that, let's shift into what I feel some of the biggest pros are with this. So cost is certainly a consideration, and I will do an individual breakdown a little bit later of, the dollars and cents of did this make sense. But another benefit that I hadn't really considered was quietness. So this unit is certainly more quiet when it's running in either washing or heating mode than either my previous washer or dryer were beforehand. It's in a room that actually adjoins my open living concept, kitchen, living, dining, living room, and I never feel that it's so loud that it causes any issue. I never have to close the door to the laundry room. Another big benefit of this is where it is a ventless heat pump setup, there is no vent that goes outside. So that means that I'm not pumping a bunch of air outside and having to let that infiltrate back in through all the cracks and crevices that are located throughout my house. So I'll make a little bit bigger deal and go in a little more detail about this whenever I'm breaking down the dollars and cents, because I think that's one of the reasons why it's so hard to say how much money did I actually save by upgrading my dryer to a heat pump unit, because you can't really necessarily easily measure the amount of heat or cooling that you're pumping outside of your house to be replaced with whatever the temperature or humidity is that's in the outside air at an individual time. This does have the app, and when it works, you could, in theory, schedule like time of use. So if you had a cheaper electricity rate during certain hours of the day, you could potentially even save a little additional money by setting that up in the app and just having it to run. That is one of the biggest benefits, in my opinion, about this being a washer and dryer all-in-one, is you set it and you forget it. You hit the go button when the clothes are in there, and they automatically go through the wash cycle, all the way through the dry cycle, and then it pops open, and by the time I wake up the next morning, everything's ready to go. So you can individually tell it that you just want to run the wash cycle or you just want to run the dry cycle. Just whenever you throw that stuff in there, you select or deselect the one that you don't want to run. And if there are delicates or something that you want pulled out of the washer that you don't want going through the dryer, it does have that ability built in. So you can just tell it, well, do the wash and I'll tell you to do the dryer later. Or you can have it set up so that it messages you via the app once it's done washing, and it'll have a certain pause time before it starts that drying to give you a chance to get in and pull things out that you may not want to run through the dryer. So it's honestly, that's kind of nice too. Auto detergent and softener integration. So this, more or less, you fill up the reservoirs that are in the bottom of this, and it automatically senses the amount of soil that's in your clothes through its whatever its proprietary AI equipment is, and decides how much it's going to dispense from both a detergent and a softener standpoint. So it's really nice to not have to put that in for every time. It just tells you when it's low and you refill it and you go on with life. Reduced fire hazard. So yes, there is more lint in various places throughout this unit. However, the temperature never gets anywhere close to combustion temperatures. And you're also not, potentially allowing a lint line, vent line to lint to accumulate in a vent line, potentially leading to an increased fire risk hazard. So to me, it's kind of nice because, as you can tell, I do live in a quasi-log home here. So I do have a very wood-intensive structure. So anything I can do to reduce chances of fire is kind of a win, in my opinion. Another nice thing about this is this does not require any 240 volt receptacle to use. In fact, this literally just plugs into the same 120 volt receptacle that my washing machine alone plugged into before. And rarely does it ever pull more than 500 watts. So it's not an energy intensive thing. And I'll show some clips and things of typically how much a load takes from a overall kilowatt hour standpoint. But it's certainly more efficient to run than the old resistance, electric dryers, or potentially more cost effective and cheaper to run than maybe a gas dryer as well. So with that, probably those are most of the benefits that I've led to. And with that, could probably slide into the dollars and cents for, these are the dollars and did this make sense? Column C is going to contain all the kilowatt hours that I used for the dryer itself. So this is the old dryer. This is not the new dryer. Column D is going to contain the amount of money in kilowatt hours that I used at 13.5 cents per kilowatt hour. So if you guys pay more or less than 13.5 cents, feel free to just adjust it based off of whatever your kilowatt hour use is. So you'll see I have this broken down into two separate years. I have from September of 22 to August of 23, and in that time I used 1,197 kilowatt hours. And in the following year, from September of 23 to June of 24, I used another 1,080 kilowatt hours. So I did this for two reasons. One is it pulls off my energy emporia in 12-month chunks, but it also makes it a little easier to see exactly how much I spent for one whole year. The row below that in 7 is 22-month running total. So in the 22 months that I was tracking my electric dryer usage, in electricity alone, I used 2,277 kilowatt hours, and in theory, that cost me $307.40. If I cost average that over a month, I used roughly 103.5 kilowatt hours per month during that time frame, and that came out to almost $24. Of that 103.5 kilowatts, I averaged 4.5 kilowatt hours per load in the old vented dryer, and that came out to an average of about 23 loads per month. With the new heat pump dryer that is ventless, I am averaging approximately 1.2 kilowatt hours per load. That comes out to 27.6 kilowatt hours monthly, or about $3.73. So I had actually hoped that the app was going to be tracking my energy usage on the dryer, even though I didn't have it attached to the app, and that hope was in vain. So for those of you wanting to use the app itself to track your energy usage, you are basically going to have to make sure that you get yours connected and keep it connected for that data. So I also have no idea how long the app itself will store your data. But what I did to come up with this number was I did actually attach it to my Energy Emporia, And I verified that against what the unit itself was saying the average use was at the end of the cycle. I'm going to throw up some still shots here and show you the last handful of cycles that I actually do have records for, so that you can kind of see where this data is coming from. All right, I'm just going to let these kind of cycle through as I'm talking about some of the various aspects of it here. So you will notice that at the end of every dry cycle, if you can see it, it'll actually pop up some of the stats for what happened during that dry cycle. So this includes the size of the load that it thinks it used, how much water was used, how much detergent was used, the amount of softener. It'll also tell you the length of time that that specific load was in the wash and dry cycle, and this is a combined data point, as well as the estimated kilowatt hour energy usage. And I did find this to match very closely with what my Energy Emporia app recommended. And I do feel like that this stuff does show up on the app if you can get it connected. So it's a little more convenient there to see some of this stuff. But I like the fact that it does show me everything at the end of it, but without the app, you kind of might miss it because it only flashes up on the screen for a set amount of time before it goes into sleep mode. One other quick note about wattage draw here, guys. As you can see here, the maximum this thing pulled during this laundry cycle was still under 800 watts. The old unit used to regularly pull between 5 and 5,200 watts. Now that you have a little better idea of where the actual energy usage and the averages for the data set that I'm using are coming from, let's talk a little bit about the things that are not so easily measured. Air infiltration is probably the hardest one to measure overall. If we take this dryer unit and assume that it is pumping 200 CFM per minute of airflow to the outside, the length of time of my average cycle with my old unit was about 75 minutes. And yes, that was anywhere between 60 and 90 minutes to dry the load. But if I assume that I had a larger dryer drum, which I did, I had a 7 cubic foot drum, I'm on a higher end of the CFM amount of air that's pushed out of my house. And that air, when it is pushed out, it's going to actually place your house envelope under a negative pressure, which means that it's going to replace that air with whatever the outside air is at that time. Unfortunately, depending on what the temperature is outside, this can cause a pretty big difference and makes it really hard to know exactly how much energy you did or didn't use, because now you're saying I not only had to use the electricity that it took to run the washer and dryer, but I also had to heat or cool the air that infiltrated from outside and came back into my house. So this is one of the reasons why it's super hard to actually pinpoint how much energy you actually save by getting rid of a vented dryer and going to a ventless dryer. Other considerations here would be overall water use. So this is a high efficiency washer dryer, so I'm sure that I'm using less overall water than I used in my old unit, but I have nothing to really compare that to. Another consideration could potentially be hot water usage. Again, since I'm using less water overall, I'm likely using less hot water as well. But these two items are more or less so varied and random that I really don't have anything to compare them to. So for the intents and purposes of this, I'm just going to act like they don't exist. So from there, if we look at the cost of the unit, I spent $1,665 to buy this unit. If I have a savings of 3.3 kilowatt hours per load, that roughly equates to $10.24 per month. That means that my return on investment to actually pay for this unit in electricity savings alone would be 13 and a half years. So 13 and a half years, while not actually correct, is still really not that bad in my opinion. So I was going to have to replace this washer and dryer unit anyway. And given that the cost of this is really not that much more than a comparable washer and dryer individual vented unit would have been, the fact that it saves me money at all is honestly just kind of a bonus and a big win. But I don't have any hard numbers, but for my energy nerds out there, I do have a scenario where we could potentially put a little more emphasis on what this air infiltration means and why this matters so much. So if you guys remember, I had basically 15,000 cubic feet of air that was replaced during running my old unit for approximately 75 minutes. Let's talk about the importance of 7 degrees. So 7 degrees, as you can see here, is actually the temperature that it was at my house when I woke up the other morning. 7 degrees also happens to be the HVAC design temp for my area. So if you've ever wondered how companies design your HVAC system, there are a set of guidelines out there more or less stating that if you live in this area, this zip code, this county, this will be the design temp for your HVAC. And what this means is that 99% of the year, it will be that temperature or above. So for me, that's 7 degrees. So why is this important? Well, if you ask how much energy it takes to heat 15,000 cubic feet of air from 7 degrees to 70 degrees, that's a 63-degree temperature delta, and the answer is 17,010 BTUs. Which then brings up the question, how much energy does it take to create 17,010 BTUs of heat? The answer to that is 4.985 kilowatt hours. But let's call it 5 kilowatt hours just to make things easy. So the last temperature we need to talk about is 38 degrees. Why? Because 38 degrees just happens to be right in the middle of 7 degrees and 70 degrees. It's also a very much more reasonable temperature for my time, considering that mathematically I should only see 7 degrees 3.65 days per year. But there's another reason why 38 degrees is also important in this circumstance. And that is that it just happens to be the exact temperature average that I had here last month, taken directly off my power bill. Lastly, we're going to make one final assumption. We're going to say that if it is 7 degrees outside, you are heating with electric resistance heat. Now, I know that some of you out there might have wood heat or propane or natural gas, but really there's not an easy way for me to kind of set this up on an even keel. So for the intents of this next spreadsheet, we're just going to assume that 1 watt of heat equals 1 watt of power and vice versa. Okay, with the stage set, let's see what it would actually look like if I did do a load of laundry in my old vented dryer at 7 degrees outside. So we'll start with the 4.5 kilowatt hours of energy that the dryer itself needs, just the electricity that it needs to run. But then let's also take into consideration the 17,010 BTUs of heat that are required to replace the existing air that's coming back into the house from infiltration because I'm venting all that air outside. That brings my total load energy use to 9.5 kilowatt hours, as opposed to the 1.2 kilowatt hours that my ventless dryer uses because it's not pumping any air outside. So that comes to a difference of 8.3 kilowatt hours, which also comes to a difference of 7.9 loads. So I could do 7.9 loads in my ventless dryer as compared to 1 load in my vented dryer if it were 7 degrees outside. So let's again consider that this is the worst case scenario, and I somehow managed to do all 23 loads of my laundry in that same day while it was 7 degrees outside. That means that I would have spent 218.5 kilowatt hours as compared to 27.6 kilowatt hours in my ventless unit. So roughly a savings of $27 for the month. And again, this is a very unlikely scenario, and I understand that. But what about our much more reasonable 38-degree day? That cuts the energy usage in half to 2.5 kilowatt hours, just from the amount of energy needed to heat the air. But it remains the 4.5 for the actual energy used by the dryer. So our total energy use for a load of laundry in this instance is 7 kilowatt hours, as opposed again to the 1.2 kilowatt hours that the ventless dryer uses. That's a total difference of 5.8 kilowatt hours of savings and equates to a difference of 5.8 loads for the same amount of energy. Applied to the same 23 loads that I usually do in a month, that means I would use 161 kilowatt hours of average energy, or $21.73. Public service announcement. If you're ever going through one of my videos and came up with a different number than I did, or just can't come up with where I came up with some of my information or numbers from, drop something in the comments section and just ask for clarification. If I can, I'll try to steer you to where I got my numbers from. But if it's wrong, then I'll actually go in and correct it, because the last thing I want to do is have a bunch of incorrect information in here. So shout out to my comment sections for catching that I had a pretty gross error in my original BTU calculation, and I reshot this entire later half. Thanks, guys. So now you have some idea of why it's actually just almost impossible to assume the amount of energy that you will actually save by switching to a ventless dryer. Now, do I think this was worth it? Absolutely. It's still savings. So as a return on investment of 13 and a half years on something that I wouldn't have saved money on anyway if I hadn't gone with the ventless, I think this is really pretty awesome. In addition to that, I'm not having as much trouble keeping my rooms warm during the winter or cool and dehumidified during the summer. So all in all, I've been very pleased with the unit. I've had so far no issues with it, and I would absolutely buy it again. Guys, that's probably it for this one. I'm gonna wrap it up here. If you stayed this long, thank you, my energy nerds. If you do have questions, drop a comment. If you like the content, if you would, give it a thumbs up, maybe subscribe. If not, no hard feelings. Guys, thank you, and I'll see you in the next one.